Hello everyone. In this video lecture, we are going to see what are asymptotic notations in design and analysis of algorithm. So let's directly move into what is asymptotic notation. So asymptotic notations are units to measure complexity. So we have already seen what is the complexity, and we have seen some examples, some programming examples. And then asymptotic notation, the second definition, is a way of comparing functions that ignores constant factors and small input sizes. What exactly does it mean? We will see by an example. We will clearly see what it means. Another definition of this asymptotic notation can be when the input n. See, whenever we encounter this small letter n, this basically means number of inputs. So whenever the number of inputs become very large, then we use these asymptotic notations to see what is the complexity of those programs or algorithms. Okay. So let's see how, okay, before going into the types of asymptotic notation, I have used this example. Okay. So let me read this out. Let's understand this with the help of an example. One algorithm which runs on a system takes these many machine instructions. How many instructions it is taking? 6n square plus 50n plus 80. Okay. And on the basis of these instructions, separately, we have drawn a graph. Now, 6n square is drawn by the red line. This red line is representing 6n square. And this blue line is representing 50n plus 80. Or in terms of this question, 6n square instructions are represented by red line and 50n plus 80 instructions are represented by the blue line. So we can clearly see that the order of growth of these instructions or this program which is giving out these many instructions 6n square plus 50n plus 80 is dominated by this term 6n square. Okay, so when the value of n becomes very large, this 6n square is all we need to see to check what is the order of growth of our program or algorithm. So in order to do that, and while using asymptotic notation, what we do, we remove or we neglect the lower order terms. Okay, we neglect these lower order terms. Okay, so moving on, what are the types of notations? We have three types of asymptotic notations. The number one notation is big O notation. It is also called as capital O notation. It can be represented as big O notation. It can be represented as upper bound notation. Any name can be used. Okay, generally big O notation is the name we use. The second type of notation is omega notation, or we can say big omega notation. Okay, and the third notation which we use is theta notation. So what are these notation? How we use it? We will see just in a moment. Okay, so let's first understand what is a big O notation. Okay, so see these asymptotic notations, what we are basically doing is we are basically in asymptotic notation, we are trying to find a mathematical formula or mathematical way to categorize our algorithm in worst case, how to represent it in worst case, average case, and best case. Keeping in mind that lower order terms are going to be neglected. Okay, this is what we are trying to achieve with asymptotic notation. Okay, so uh, let's see how we can define it by mathematical notations. Okay, let me just remove these. Okay, so what we are going to do is we are going to take a graph. See what I want to achieve, what we want to achieve in big O notation. So big O notation, what basically do? The big O notation is the most important notation. Why it is the most important notation? Because by big O notation we represent the worst case, and we are always interested in the worst case. So we see we are given a function fn, and n is going to be the number of input. N is always going to be the number of input. Now I want to find what is the worst case of this function fn. The fn can be anything. Fn can be n square, 5n plus 3, n log n, anything. Okay, so what is or how to represent this fn? How should we represent this fn? What in what mathematical way can we represent? So let me just draw a graph, and in the x-axis this is n, this is number of input, and it is getting increased with respect to time. And let me draw this fn graph. Let's say this is fn graph. Now how to bound it such that I can find the worst case? So we will bound it by another function named as cgn. Why I have drawn it above it? Because we are trying to find the worst case. So this cgn function is going to represent the worst case with respect to fn. And as you can see here, the lines are coming up and down, but after this point n0, these lines are symmetric in nature. Means the cgn is going upper and the fn is going lower. Okay, so how to build a mathematical formula out of this? See, as you can see from the graph, this fn is less than equal to cgn. Okay, we can write it like this. We can say this fn is less than equal to gn, and this fn is greater than equal to 0. We can establish this. This is the mathematical uh, formula for big O notation. If and only if n0, this n0 should be less than equal to n for some positive constants. What are the positive constants? For some positive constant c, comma n0. Okay, these are the positive constants. If these conditions are true, we can represent it in big O notation. Now here I have taken one example. Now here fn is 3n plus 5 and gn here is n. It is not written here, but gn is n here. So if we apply these things here in this equation we have formulated. So fn we have 3n plus 5 is less than equal to cgn. Gn is n. Yes. So is it true? We have to check if this equation is true. This less than equal to sign is true. So let's take it for n is equal to, let's say, 1, and let me freeze the constant value c is equal to 4. So when this happens, let's see what this equation behaves like. This equation will behave like n is equal to 1. So left hand side will become 8 is less than equal to c is 4 into 1. This is 4. So this is not true. Then we say n is equal to 2. C is constant at 4. C is 4. So Left hand side will become 6 plus 5, 11, less than equal to 4 into 2, 8. So again it is not true. Let's try n is equal to 4. C is going to be this only. And the number of inputs are increasing, as you can see in the graph like this. Okay, so 4, 12 plus 5 is 17, less than equal to 4 into 4, 16. Again not true. Let's try for n is equal to 5. This is same. N is equal to 5 is 20, less than equal to 5 into 4, 20. Now here we are getting the correct result. Let me try it for another higher value. 6, 6 3 are 18, plus 5 is 23, less than equal to 6 into 4, that is 24. So this is also correct. So as you can see, till here means till n is equal to 4, we were not getting our equation correct. But all the values after n is equal to 4, we are getting the correct answer. So these values n is equal to 1, 2, 4 lies here, where some anomaly can arise. Okay, but after this, after n is equal to 5, we will get this result. So we can say that if we are able to find the correct solution for this equation, we can say Fn is equal to big O Gn. Okay, we can say it like, okay, so we can say part will come here and if part will come here. Okay, so we can say Fn is equal to OGn. So here in this example, Fn is equal to O of Gn. What was Gn? N. So this is the solution. So this may come in your semester exam, like example would be given and they will say how to find this. Okay, so to big O we find the worst case, and if it is written big O, then we know that this is the worst case. Next, we have ohm notation. Now ohm notation also we have to find the mathematical formula first, and ohm notation is used to find, or we can say represent, best case. Okay, so here we have a graph. We will draw a graph. This will represent n and this will represent the time as before. And now we have to draw a graph keeping in mind that we have to find the best case for, let's say, some function fn. Okay, so best case is definitely going to be represented by a line which is lower than fn. So I have drawn a line lower than fn. So this line can be equal to or lower than fn. Okay, and here we have n0 as before. Now we say if as we can see from the graph, cgn is lower than or equal to fn. It can be lower or equal to fn. So we will write it like this. And cgn is greater than equal to 0 if this is true for n0 is less than equal to n, and n0 and c are some positive constant. If we are able to prove these things, we will say Fn is equal to ohm of Gn, or sorry, big omega of Gn. We will say Fn is equal to big omega of Gn. Now, to see this, we have taken an example. This example is same as before, but this time we will represent this in the form of big omega. So what is the example? Here Fn is equal to Cn plus 5 and Gn is equal to n, and just put it in this equation. Okay, so Gn is n less than equal to Fn, 3n plus 5, and let's put some value for C and n. Let's put C is equal to 1, and let's try n is equal to 1. So for n is equal to 1, C is equal to 1, we will see it going to be like this: 1 less than equal to 8, so it is correct. Let's try it for n is equal to 2, so 2 less than equal to 11. So this is we are getting correct on the first time. So yes, we can represent it like this, and we will say therefore Fn is equal to ohm of what is Gn? N. Okay, like this we can say it. Okay, and this is how we can represent it in the form of big omega. Moving on, let's see the third notation, theta notation. Now this theta notation is used to represent average case. Now average case, we are not always able to find the average case, but let's represent it mathematically. How to represent it? This is the number of inputs, time again. Now average case means all the cases from the best case to the worst case. I have to find a mathematical formula from the best case to the worst case. So let's see, let's say I have this function Fn, and this function needs to be represented by both, in terms of both, or we have to try all the possible solutions. So we have to take the graph to be, one part to be C1 Gn, which will represent the worst case, and another line in the graph which will represent the best case. And this is why it is called as tightly bound, because it is bounded by both the upper bound and the lower bound, because we have to find the average of all the cases. So we have taken these two lines, and here we have written n0. So we will, let's write the mathematical formula. If C2Gn is less than equal to Fn, this function is less than equal to C1Gn. Okay, and C2Gn should be greater than equal to 0, where n0 is less than equal to n for some positive constant C1, C2, n0. Okay, then we can say, then we can say Fn is equal to theta Gn. Okay, this is the uh, symbol used to represent the theta notation. Okay, so let's take this example. Here Fn is equal to n square plus 3n plus 7, and Gn is equal to theta n square. Okay, so let's put it in this equation. So here we are given C2Gn. So let's take C2 to be 1, C1 to be 2, and n, value of n to be, let's start it with 1. Okay, so what it is saying, C2Gn is 1 into Gn is n square, less than equal to Fn is n square plus Cn plus 7, less than equal to C1Gn. C1 is 2, into Gn is n square. Okay, let's try this. So for n is equal to 1, what should be the value? For n is equal to 1, let's say it's going to be 1 less than equal to 1 plus 3, 4 plus 7, 11 less than equal to 2. So is it correct? No. So let me jump to n is equal to 3. So it's going to be 9 less than equal to 9 plus 9, 18 plus 7, 25 less than equal to 9 into 2, 18. So no, this is not. Let me jump. I'm skipping 4. I'm just jumping ahead. I need to find it fast, so I'm jumping ahead. N is equal to 5, so 25 less than equal to 25 plus 15, 40 plus 7, 47 less than equal to 25 to 50. Yes. So from n is equal to 5, we are going to get the correct answer. Just try it for n is equal to 6 also. So this becomes 36 less than equal to 36 plus 18, 30 plus 40, 48, 54 plus 7, 61. I think I am correct. Then 36 into 2 is 672. Yes. So we are getting the correct values now. After n is equal to 5 and onward, we are getting the correct value. So because for every value after n is equal to 5, it is correct. So we can say Fn is equal to theta of what is Gn n square. So you can see essentially, you can say this. So essentially what we are saying, or what we are doing, we are basically neglecting the higher order. We are basically neglecting the lower order terms and representing in the terms of higher order terms. This is also one of the purpose of asymptotic notation. Okay. So thank you for watching this video. Let's meet in the next lecture.